this is going to search for if the string starts with A and is followed by a B. So it will match in this case because it does start with A and is followed by a B, but it will not match in this case even though it starts with an A because it's not followed by a B. So out here is basically us using the re.search to basically find these patterns. The next symbol that we will come across is the dollar symbol. So the dollar symbol that you can see here is used to check if a string ends with a certain character, and we have already seen how this is used in one of the earlier examples. So this is going to check basically this expression will check if the string ends with A. So this string is basically the character A, so it will match. This also ends with A, so it will match. And this particular string does not end with A, so it will not match. And we are going to do that using the re.search over here. So as you can see, it finds a match in the first character itself here. In this case, it finds a match in the last character, but in CAB, there is no match, so it returns us a none. Another example is of the meta characters is star. So this is the symbol for star, and what the star basically is used is for checking if there are 0 or more occurrences of the pattern to the left of it. So now if you see here, what this will check for is there any form of M and A that occurs before N? And it's very important to note that the N has to follow the A in this case. So let's look at these examples and what will happen. So if I checked it with M and N, this is actually a match because N is followed by 0 occurrences of M and A, which is, it might seem a little weird, but it is technically the truth, because the star symbol doesn't check for the existence, it just checks for if N occurs, it must occur after an A, or the A should not be there itself in this particular string. So as you can see here, the N occurs after an M, and it's fine because there is no A. Now you will see when it will not work. So M, A and N is obviously fine. M triple A N is also fine because N follows an A and there's an M here. This, however, main will not match. Now why? Even though we have M and A and we have an N, you see the N is immediately followed by an I. N follows an I immediately, or the N is preceded by an I immediately. And this is a no match because the strict condition in the search is that N must precede an A if the A exists. Again, in woman it will match because N follows an A over here. So we're just going to use the re.search for these examples that we saw over here in terms of code using the re.search, as you can see here. Finally, we have the next meta character, which is the plus symbol. Yes. So the plus symbol matches one or more occurrences of the pattern left to it. Now this is very similar to what we saw earlier in terms of the star, except now in the plus, the key difference is we're looking for one or more occurrences instead of 0 or more occurrences that we were looking for in the case of star. So when we say one or more occurrences, now we need what is there to the left of the plus sign. A 0, no occurrence of it will not be allowed or will not cause a match. So let's see now what we're going to do here. We're going to use the same expression, except we're going to replace the star with the plus sign. So now what we're going to say is, okay, we need M and A, at least one occurrence followed by an N. All of these conditions have to be met. So again, if we took the first example, M and N, this time it will be a no match because there is no occurrence of an A over here for preceding the N. So it's a no match. M, A and N is a match because, well, this is perfectly fine. M, triple A and N is also perfectly fine. But if you look at M, A, I and N, much like earlier, the N is preceded by an I and not an A. So there is no match. And again, woman is perfectly fine. And we basically execute the same thing through the search function in this piece of code. The next meta character is the question mark. The question mark symbol matches 0 or 1 occurrences of the pattern to the left of it. So let's see what this does. So now we saw the star which was 0 or more occurrences of the pattern to the left of it. We saw the plus, which is 1 or more occurrences of the pattern to the left of it. Now we will see the question mark, which is 0 or 1, only 0 or only 1, and not 0 or more or 1 or more, which was the previous cases, only 0 and 1 or 1 occurrences of the pattern to the left of it. Again, we're going to see the same expression, except we're going to replace the meta character with the question mark. So now let's see what happens when we match. So if you see here, M and N is a match because there is 0 occurrence of A and 1 occurrence of M preceding N. So this is fine. This is also fine because there is 1 occurrence of A and M, and then it's followed by an N. This will not be fine because now we have 3 occurrences of A, which is followed by an N. We're only looking for 0 or 1. This again, main will be a no match for the same reasons that we have already gone through, and woman will be a match again for the same reasons. And we do the same thing using the search function in this piece of code. The next meta character is the braces character. Now the braces character is interesting because what we're going to do is we're going to see if there are, the typical syntax for a braces is n brace followed by some integer n, comma, integer m, and then close braces. So what this means is we're looking for at least n and at most m repetitions of the pattern left of the braces. Let's see through an example. If you see this expression, we're looking for at least 2 and at most 3 occurrences of the character A in our test strings. So let's see what happens in the first case. We have no matches in this case because this part of the string contains only one A, and even this part of the string only contains one A. We're looking for at least 2 and at most 3. This part will contain one match, the second example, because the second part of the string actually contains 2 A's for two repetitions of A's consecutively. But this in the third example, you can see both the strings actually contain matches, so we get 2 matches because, as you can see here, there's 2 A's here followed by 3 A's here. Now when we look at this particular string, let's look at what happens now. So what we're going to find is that this thing is perfectly fine. So we have 2 occurrences of A, but now we have 4 occurrences of A, but what the search engine is going to recognize is these first 3 A's, and it's going to see, okay, so there are 3 occurrences of A and I already have a match. It's not going to consider this 4th A in the search. It will just look at the first 3 and it say, okay, there are 3 A's and my match is fine. So again, there are 2 matches in this case. Again, we're going to use the search function initially, and you can see in each of the cases there is a match except for the first case, which is this case. Now let's see the find all option and see what happens when we do the same thing using find all. So when we use find all, it basically gives us each of the instances where the match has occurred in each of these lists. Now let's try to use a slightly more complicated example where we combine different meta characters and we create a more sophisticated expression that we want to search in our test strings. So if you look at this expression, what we're looking for is 0-9. Now a dash symbol is valid in Python using regex because what this basically tells it is that it's looking for either 0, 1, 2, 3, 4, so on until 9. Basically any of the digits. We're looking for any of the digits from 0 to 9, and we are going to check if at least 2 and at most 4 occurrences of digits, if they are there or not in our particular code. So let's see what are the matches that happens when we use it on test strings. So if you use it on this string, you can see it will find one match. This basically this particular part of the string where it says 1, 2, 3. So this is 3 occurrences of digits, so it's fine. Now when we look at this whole string, 12 and whatever this is, you will see this will not find a match here. This obviously will not because these are characters. But if you look at this part, it will find matches in terms of the first 4 and then 7 and 3, the next 2. 1 and 2 again, there are no matches because there's only single occurrences of digits. We're looking for at least 2 and at most 4. So if I use a find all, you will see like what all it will return. So for the first test string, what it's going to return me is, it's going to return me 1, 2 and 3 as you can see here. But now if you look at this test string, it's going to return me 12. It's going to return me 3, 4, 5 and 6. It's going to return me 3, 4, 1 and 2, but not 7 because we're looking for at least 2. And then it's going to return me 4, 5, 6 and 7 followed by 8 and 8 as you can see in this list over here. Now if we use curly braces with only one digit, it's basically telling the search engine that we want exactly so many repetitions of the preceding whatever expression that we have. So when we do this example, for example, we are basically saying that we want x followed by a dash, and the dash has to occur at least 3 times in our particular expression, and then it should be followed by an x again, which will not match in this case because there are only 2 dashes, and it will match in this case because there are exactly 3 dashes, and it will again not match in this case because there are 4 dashes. As you can see here, none followed by an object match followed by none. Next we move on to the alternation meta character. And as the word suggests, alternation is basically looking for some alternate form of A and B. So A should be followed by B, and basically this pattern has to keep going on. So in the first string over here, this pattern will not match. in the second string over here, we will have a match because we at least find an A, even though there is no B. But this is still considered a match because we did find an A at least. Over here, we'll have 3 matches because we have A followed by a B followed by an A again. So if we did a regex expression for this, we would basically find these many matches for each of these examples. The next meta character is the group. Now a parenthesis is basically used to group subpatterns. So let's look at an example to understand what we mean. Now if you look at this complicated expression, what this means is that I want some form of x and z. The x and z have to occur together. But before that, what I want is some form of A following B following C. Some sort of alternation between A, B and C. So this part, as you can see here, is kept in a parenthesis because I want this whole condition to basically occur before I find an x and z. So let's look at what happens here. In the first case, we don't have a match because this parenthesis condition is not being met. X and z is preceded by a space, or basically the A and B is followed by a space. So if the space didn't occur, we would actually find a match, as you can see in the next example. Here you can see A and B occur. Basically this initial condition is met, followed by x and z. So there is one match. So it's fine for us. Now if you look at this slightly more trickier one, what you can see is we have 2 matches in this case. First an A followed by x and z, and then we have C, A and B. Now this is perfectly fine because we are looking for a B followed by an x and z. We're looking for either of these things. We're looking for some form of alternation of these things followed by an x and z. And we can get that over here. We get B followed by an x and z. So you'll get 2 matches in this case. Now let's go through the concept of grouping constructs. Now that you've seen many meta characters, you've seen how parenthesis works. Let's look at grouping constructs. So grouping constructs break up a regex in Python into sub-expressions or groups. And this serves 2 purposes. One is the grouping part, which basically says that a group represents a single syntactic entity. And any additional meta characters apply to the entire group as a unit. And then there's the capturing part, which basically tells us that some grouping constructs also capture the portion of the search string that matches the sub-expression in the group. And you can retrieve captured matches later through several different mechanisms. So let's look at basically what we mean by this example over here. So if you see this expression has a plus sign. So we're looking for, as you know, a plus looks for one or more occurrence. So this will basically check for one or more occurrence of the character R only, because there's no parenthesis as in this example. So this plus is next to an R, and it's going to check for basically whether one or more occurrence of R happens preceding B and A. But if we actually put B, A and R in a parenthesis followed by plus, it will actually check for the entire string BAR, and it will check one or more occurrences of BAR together. So if you look at these 2 examples, when we use this on these examples, you can see that these are fine, like these matches are fine. But if I used this parenthesis, then these would be the acceptable matches. And like BA triple R would not be a match if I use parenthesis, as you can see here. So this is how grouping constructs work and how parentheses work. So look at some other examples. So what this will do is FOO has to be optionally followed by BAR, and BAR must exist together. And this is because we have a question mark here. This question mark symbol tells us that there should be 0 or 1 occurrences. Similarly, this particular complicated expression is checking for one or more occurrences of whatever we saw earlier. Basically, this whole thing is followed by a plus. So we're looking for this whole sequence for one or more occurrences of it. COW is simply just COW. We're looking for this pattern. And this is going to check for 0 or 1 occurrence of COW because of the existence of the question mark preceded by the parenthesis. In this video, we're going to continue our discussion on regular expressions. Now that you know the basics of regular expressions, let's continue our discussion with special sequences. Now, in an earlier video on strings, you might have encountered what is an escape sequence and how we use the / character to generate these escape sequences. And an escape sequence is basically, if you remember, something that we use to either give a certain special meaning to characters that are otherwise ordinary, or it is used to remove the special meaning that are inherently present in certain characters that we call meta characters. So let's look at what special sequences are in relation to regular expressions. So the first one we're going to look at is the \A. which is used to match if specified characters are present at the start of a string. So out here, if you can see, we are checking if the word the is present in these two strings. So we would get a match in the first case over here because this starts with the word the, but in the second case we won't get a match. And this is how we're going to check it for the same thing using the find all function. So if you see in the first case, it returns us an object because we do find the in the beginning of the string. In the second case, we get us empty list because this string does not start with the word the. Now the next one that we'll look at is \b, small b. Now this is used to match if specified characters are at the beginning or at the end of a word. So when you use \b and then you follow it up with whatever you're looking for, it would look for those particular characters or that pattern if it exists in the beginning of a word in a string. So if you look at the first example, it starts with FOO. And in the second example, you see this portion of the string or this word is actually also starting with FOO. So it will also match. However, in this string, which is very similar to the second one, we don't have a space between A and F, and it's basically one word. So this does not start with FOO, but it actually starts with AFO, and it won't match, as you can see here. Now similarly, if we wanted to check if something exists in the back of a string, at the end of a string, we type what we want to search for first, and then we follow it with a \b. And then if you see here, it will match in this first case, it will match in the second case because this part of the string ends with FOO, but it will not match in this case because, well, we removed the space, so now this whole thing becomes the string that we're looking for, and it does not end with FOO anymore. And this is basically us just checking it through the find all function. Now the next special sequence that we will be looking at is the /B, which is basically the opposite of what we just saw. This matches only if the specified characters are not at the beginning or the end of a word. So if you see here, this is checking if FOO is not at the beginning of these strings. So in this case, there will be a no match. In this case also, there will be a no match. In this third case, there will be a match. Similarly, if we wanted to see if something does not end with a particular string, we would type that whatever pattern we're looking for, followed by a \B. And then we can use the find all function to generate us lists wherever we find such objects, find such matches in our particular test strings, like we have done over here. So the next one that we're going to look at is the \d. And this matches any decimal digit, which is equivalent to doing a square brackets 0-9. As you must have seen earlier. So if we did a square bracket 0-9 and if we did a search or a find all or a match, it would look for any of the digits between 0 and 9. So a similar thing can be done using a special sequence \d. So as you can see, there will be 3 matches in this case because 1, 2 and 3 digits exist. Whereas in this case, for the word Python, there will be no matches. So these are certain examples where we are doing the same thing using the \d. Now we have another one, which is the \D, and this is just basically the opposite. It matches for any non-decimal digits. It's also equivalent to typing a caret inside square brackets with 0-9, which if you remember from the previous video, is basically asking us to check for anything that is not the digit 0 to 9. So this is basically, we're going to check in these two strings if there is no digits, no non-decimal digits. So if you see here, we will find 3 matches, A, B, and the double inverted commas. And in the second string, we will find no matches because this is fully just digits. Next, we have \s. Now this matches where a string contains any white space character. So this is equivalent to doing a check for all of these. So this is like \t is a check for tab space, \n is a check for break line, and then /r, /f, /v are their own checks for different sorts of white space characters that you can see by just looking it up, honestly. But yeah, so if you simply do a \s, it would actually be the equivalent of searching for any of these white space characters that we generate. So if you see here, when we do a \s on this string, you can see that there is one space over here. So it will give us one match because there is one white space, which is just the normal space here. And in the second example, there is no match because there is no white space here. Similarly, /S now, as you might have noticed, is basically checking for a string which does not matches in a string wherever there is no white space characters. So it's basically the same as doing caret/t/n/r/f/v in a square brackets. So this is basically a simpler way of doing the same thing using square brackets and a caret symbol. So if you see this expression \S, now we're looking at A space B. So over here, if you see, it'll match for all the non-spaces. So it's going to match for A and B. So we're going to get two matches here. Whereas an empty string does not contain, well, it does not contain any non-white space character, since an empty string is basically a white space character on its own. So this will give us a no match. So the next special sequence that we're going to look at is the \w. This matches any alphanumeric character, which is the equivalent of doing A to Z in small and then capital A to Z, and 0 to 9 followed, and also an underscore check in square brackets. It's important to note that the underscore is considered an alphanumeric character, hence why we include it over here. But yeah, this is the \w, small w, which basically checks for any alphanumeric character and matches it in a string. So if you see in this first case, it will find 3 matches at 1, 2, and also at the letter C. These others are not alphanumeric characters. Whereas in this string, none of these are alphanumeric characters, so we will get no match. Again, much like the other examples, there's a \W, which will check for any non-alphanumeric character. And it's the equivalent of doing whatever we did before in the square brackets, just with preceded by a caret sign. So if you see here, we have this string where we have a bunch of characters. Well, yeah, only one of them, this percentage symbol, is a non-alphanumeric character. So we will get one match over here. But in this case, in this string Python, we will get no matches because they are all alphanumeric characters. We're just doing the same thing here with a bunch of different examples using the findAll function. Now the \Z matches if the specified characters are at the end of a string. Now don't confuse this with small b, because the small b checks for a string and it checks each and every word in the string individually and checks if any of the words ends with a particular thing or starts with a particular thing, but it checks each word individually. But in this case, the \Z will check the string only and not each word. So if you see the difference here, when you use \Z, it will match in this first example, but it won't match for the next two. But if you used \small b over here, it would actually match not only in the first example here, but it will also match in the second example, because it would check this word individually and it will find out that, yeah, there is a match here as well. So it would actually match in the second example as well. In this video, we will be covering the topic of closures. Now, before we understand what a closure is, we have to understand what is a nested function and non-local variables. Now, a function which is inside another function is known as a nested function. Nested functions are able to access variables of the enclosing scope. So if I define this function called outer function, where I pass some argument called text and I store that in a variable called text again, and if I create a function within this called inner function, and I want to print whatever this variable is in text, when I execute this, it will be able to access this variable because it's within the enclosing scope. So if I said outer function hey, this gets stored in the variable text, and then the inner function will print that variable, which is basically the string hey, as you can see here. Now, inner function can easily be accessed inside the outer function body, but not outside of its body. So here, inner function is treated as a nested function, which uses text, this variable text, as the non-local variable. Now, a closure is a function object that remembers values in enclosing scopes, even if they are not present in memory. It is a record that stores a function together with an environment. It's a mapping, basically, that associates each free variable of the function, which are basically variables that are used locally, but are defined in an enclosing scope, with the value or reference to which the name was bound when the closure was created. A closure, which unlike a plain function, allows the function to access those captured variables through the closure's copies of their values or references, even when the function is invoked outside the scope. So let's look at an example to emphasize on what was just said. So again, I've defined this function outer function where I'm doing the same thing. Now I've defined the same inner function where I'm going to print the same thing. Now it's very important that when I return over here, what I'm going to return is inner function, but it's not going to be a function call. This is important to create our closure. So we return inner function, but without using the call as we do over here. And what this return will do is basically to create the closure, where the inner function will remember the values of the variables stored in the enclosing scope. So Now I'm going to store this outer function in an object called in a variable called my function. Now when I call this my function, you can see there'll be two things that are happening here. So once I've defined this and I've executed this, what happens out here is this function has already executed, and then I'm storing it into this. But because I've done return inner function without parentheses, I've created a closure basically. And this closure allows the inner function to remember the values that were stored in text at any point, and at every point, even after the execution of this one time. So when I execute this again for the second time over here, it will remember the value that was stored in the variable text, which is hey, which was given over here. That's why you see when I execute it for the second time over here, the first time being in this line when I'm storing it in my function, when I execute in the second time, again it will give me the result of hey. As you can see, the closures have to invoke functions outside the scope. The function inner function has a scope only inside the outer function, but with the use of closures, we can extend its scope to invoke a function outside the scope. So now let's look at this code. So this code, don't worry about what's going on here. Just know that what we are doing here is we have two functions which we defined called add x and y, which will return x plus y, and the subtract function, which will subtract x and y. So now we're going to execute these. Once we're going to execute the add over here and add logger, and we're going to execute the subtract function, and we're going to store it in sublogger. So technically we have already executed these two functions, but now since I've created an enclosure, basically if you see here, this is the enclosure that I've created. Now what happens is when I access this function from outside its initial scope, which is basically over here, this was the initial scope. When I access it outside, you will see that it still has access to these variables x and y. So if you see here, I first of all I've allowed the enclosing function to accept arguments of any numbers. So I can pass x, y, I can pass x, y, z also. But if you see here, I only have a thing for x and y. So when I want to access any value of x and y, even after the execution of this code initially, I have access to these variables x and y, and that is because I've created a closure out of that. So if you see, if I do add logger 3 and 3 over here, I'm able to get the result 6. If I do add logger 4 and 5, I'm able to get the result 9. Similarly, for subtraction logger 10 and 5, I will get 5 here, and 20 and 10, I'll get 10 here. And I can keep doing this. I can keep saying add logger, and if I say 4 and 7, so if I executed this, and now I'm going to say, let's say for example, add logger, if I said 4 and 7 here, so this still has access to my variables x and y because I've created the closure, and it should give me 11. Similarly, if I did sublogger, say 30 and 15, it should give me 15 because 30 minus 15. So let's say 30 minus 16, right? So it should give me 14 because again, I have created the closure and it has access to these variables already. In this video, we will be learning about the concept of lambda functions. Now, a lambda function in Python is an anonymous function without a name. We usually use lambda functions whenever we want to create a function type object for a short period of time. A lambda function is defined using the lambda keyword. Like a normal function is defined using the def keyword, we define a lambda function using the lambda keyword. Also, the lambda function can take any number of arguments, but it can only accept one expression as a part of it. So think of a lambda function like a sort of a temporary function object that you create whenever you want to perform a particular task or object, but you don't want to give it a name, or you don't want to define a full-blown function and give it a name like that. So over here, I'm going to give you an example of a lambda function. Let's say that this lambda function takes in, let's call it x, and so you define the function, let's call it x. Let's call it a lambda function using this keyword. Now we want, say, 2 parameters, right? We're saying, say, a and b, or 2 arguments, a and b. So we're going to pass 2 arguments, a and b, whenever we use this function, and we're going to perform some sort of an expression. Now let's write down a simple arithmetic expression for this. Once you've defined your arguments, just use the colon. Now over here we have our expression. So let's call it a plus b. So now we've created a lambda function called x, where we will pass 2 arguments, and the result will be the expression a plus b, a and b being the arguments we pass. So now let's print the result of, let's say we pass 1 and 3. So now we should get the result 4, right? Because a plus b is equal to 4. So we've passed a as 1, b as 3. Now let's execute this. As you can see, the result is 4. Similarly, you can pass any number of arguments. So we want to call some function x, let's say lambda function. Maybe say a, b and c this time. And we want to do the product of these 3 arguments. So now when we check the result, let's say we're doing the product of 2, 4 and 6. So this should be 48. And when you execute this, you get 48, as you can see here. So these are 2 simple examples of a lambda function. Now I could have done this in a different way, where I could have defined some function x, and over here I defined that it takes in 3 parameters, and then you can define some, say, return. The function basically returns you a, product b, product c. But many a times you don't need to define a full function called x. You don't want to assign some function with this name. You just want to create a temporary or a short time anonymous function with some name just to perform a simple expression. And in that case, we can use lambda functions. That's an example, by the way. You can use lambda functions in multiple places. So let's move on now. Now, for the sake of this video, what I'm going to do is I'm going to show you how the sorted function works, and we're going to learn how the lambda function uses this sorted function, how they work together. So this will give you a clearer understanding of how we use the lambda function in our code. So to start off, sorted function returns a sorted list from the items in an interval. So you can have a bunch of, for example, numbers, and the sorted function by default will give you, will return you the list of numbers in an ascending order. Of course, you can also, using a parameter called reverse, you can return a list of numbers in the descending order. You can also do this for strings, characters. So if you give it a bunch of characters, say A, E, F, G in the alphabet, it will give you, if you use a sorted function, it will give you the characters. It will return it in an ascending or descending order depending on the parameter you give. So basically this, the sorted function, the syntax is, you use the keyword sorted, then you pass the iterable, which is basically some list or some tuple. Then you give it a key. So this key sometimes we don't need to give by default. If the iterable does not contain multiple items per object, for like if it's not a tuple of multiple objects, if it's not a list of tuples, for example, you don't need to give it a key. If it's a simple list of numbers, you don't necessarily need to give a key if you want to sort it. But yeah, a key is basically the parameter which we use to tell the sorted function that we want to sort based on something, which is going to be the key in this case. Finally, the third parameter is reverse, which basically just tells us that if we want to sort in the default ascending order, or if we say reverse true, then we will sort in the descending order. Now, let's look at some examples. So I have this list over here, and I'm going to print this list. So this list is obviously a bunch of vowels, E, A, U, O, I, and this is not in the ascending order of the alphabet, right? Like we know it as A, E, I, O, U. If I print the sorted form of this list, it should give me A, E, I, O, U, a list with A, E, I, O in the ascending order. Sorry. Yeah. So now as you can see, it's given me this list as you can see here. Similarly, if I gave it a string as you know is an iterable. It's a collection of characters. So if I use a sorted function on this, interestingly, it will give me a list of these individual characters like P, Y, T, H, O, and N, but in the order that we want it to be in, which is the ascending order, of course. So if I print this, you can see it returns me the list with each character in the order that we wanted it to be in. Now you might notice, why does P come before H? That's because this is in uppercase. So what this does is, first it sorts all the uppercase characters, since there's only one, so it just places it in the first object of this list, and then it sorts all the lowercase characters that you see here. So yeah, moving on now. Now what if we wanted to say sort this in descending order? So we have this list, and now we want to sort this in a descending order. So in that case, we have to give the parameter reverse, and we have to assign the value true. So once we do this, now when we execute this, you can see we have the return as the Same list but in the opposite order. So that's how the reverse parameter works. Now let's try to understand how we use the key function or the key parameter in the sorted function. Now, of course, if we want to sort something based on some key that we want to define, we use the key parameter. So let's take an example now. So in this example, what we have done is I've defined this function called take second. So what this does is it simply takes the second element of a list of tuples. So what is this list of tuples? Well, this is random. You can see this random. This is a list of tuples. So this is one tuple. This is the next tuple. And what I'm going to do is, in this example, I'm going to create a key out of every second element in each tuple. So I'm going to create a key out of 20, 40, 10, and 13. And based on these, in an ascending order, I will sort this whole list. So what my result should be is that since the smallest of the every second object in these tuples is 10, so this will be my first object in my sorted list. Then it should be the one with 13 because this is the next highest number. So then this will be the next object. Similarly, this will be the next object, then this will be the whole next object. So you see I'm using every second element of the tuple as my key. And for that, to create a key basically, I'm creating this function which will basically return every, it'll iterate through all of these and it will return each of these second elements. So let's actually do this now. So what I have here is I am going to create a sorted list which is going to use a sorted function on this iterable, which is a bunch, which is a list of tuples. It's called random. Now my key is going to be take second. So this sorted function is actually very dynamic in the sense I don't exactly have to create a list directly each of these objects present in the tuples. I just have to define I can even pass a function in the parameter for key, and it will apply this function on the iterable that we pass over here, which is random namely, and it will use this function to generate keys, generate a key out of each second element, and based on that it will do the sorted, it will perform the sorted function. So now if I check what's my sorted list, you will see that as I had mentioned, now it's using the second objects or the second each second object of the tuple as the key. So since 10 is the smallest, this whole object is the first object. Then 13, so we have this object here, and then so on and so forth. So this is how we've used a key to do the sorting function, a key that we've defined on our own. Now similarly, we can use multiple keys as well. So just to quickly go over through this, we have this some list where a bunch of names, a bunch of tuples you can see, right? Tuples with 3 objects each within it. Each first one is always a string denoting someone's name, some student's name. The second is the marks out of 100, and the third is their age. So what we have here is, what we want to do is we want to sort these tuples in the order of first marks, and in case the marks are clashing or they are the same basically, we will sort by the age. So what we want to do is we want to first sort by these marks, as you can see here, but in case they clash, for example, like say this 75 and 75, they're the same marks. In that case, we want to sort it by the age, which is 12 and 20, which is different. So in this case, we're going to use 2 keys. One for the first key will be given the highest priority, and then if there is a clash, then we use the second key. So how do we do this? Now let's define some function, like how we defined this take second function here. This will be our function that we will pass to the key. This function basically what it does is it gives us who has the highest marks. Now since we are creating since the key works in an ascending order, so the smallest object in a key is the first object that gets returned, right? So what we're going to do is we're going to return the error, which is basically the difference between 100, which is the total marks, and the marks the student gets. So this is how we obtain a ascending order in our list, which is what which basically is what we want, because we want the highest marks to be first. So we do 100 minus item 1. Item 1 is basically the first object of whatever iterable we pass. In this case, it would be the first objects of each tuple, which is the marks. Secondly, we want age. Age is the item 2, which is each second object of each tuple. Now, what we return in this function is like this is going to be our key now. A list of errors and the list of age. Error being the marks error, the difference between 100 and the marks you obtain. So now what it's going to do is it's going to take the marks as the first key and the age as the second key when we pass this to a sorting function. So if you skip this, you don't have to look at this, but if you look at this now, we have the sorted list, which is going to be the result of the sorted function on top of what we pass, which is the participant list. Now we're going to use the key. We're going to use the key as the sorter function. So we're going to use the sorter function as a key. And when we print, if you see, we get, let me just execute all of this. So if you see here in this section, what you can see is we have the highest marks first, then the second, then the third. But if you see here, there's a clash. This guy and this guy have the same mark, 75. So now what we want to do is the guy who has a younger age should be in the first in the object. So that is how this has happened, because we've passed two keys, error and the age. So when the clash in error key happened, we went to the age key and then we did ascending order on that. And then finally the rest of the objects that you can see here. So now that we've seen how the sorted function works, now let's look at how the lambda function works using this sorted function, which was the main goal of this video, right? So let's see. So now some of you might have figured out where this lambda function will be used, right? So whenever we were using the key in the sorted function, we had to define a function and then we would pass that function as the key. So as some of you may have figured this out, what we're going to do using the lambda function is we're going to skip that process of defining a function with a new name and all that. And we're going to pass a lambda function, or we're going to use a lambda function as the key. So let's see how we do it. So initially what we've done is we've created this list. This list is a list of dictionaries that you can see. So this first object is a dictionary. Second object is a dictionary. Each dictionary contains two keys, the name and the age. And the values are something like Nandini. The values for age is like 20, 20 and 19. So we have three dictionaries in a list. So what we're going to do is we want to print what we want to do with this. We want to print these objects or these dictionaries in an ascending order of age. So obviously we want this to be first and then this and this, because 19 is smaller than 20. So let's see how we do this. So if you go here, what we're going to do is we're going to print the sorted function, or the result of the sorted function being applied on this list. So this is our iterable. Now if you see here in the key parameter, we don't predefine a function and pass it over here. Instead we use the lambda, and this lambda function is defined in such a way. So we say lambda, it will take one argument I, and then it will return basically the age index for some I, and this I is, we're going to presume an I to be some sort of an iterable which has an index called age, and which is the case in our case, right? We have a bunch of dictionaries where there is a key in each of these dictionaries called age. So we're going to use that. And now you're going to ask, like, what is I? Well, when we use the lambda function in the sorted function, this I will basically be each object that we get when we iterate upon this list. So we're going to iterate first on this. So it's going to take this dictionary and it's going to search for the age. Then it's going to take this, it's going to search for the age. Then it's going to take this and it's going to search for the age. And each of the time it will pull out what is the value for each of these age keywords or these age indexes or age keys. And out of these objects, so 20, 20 and 19, or these values, we're going to create a key with which we're going to sort each object in this whole list. Okay, so this is how the lambda function will work here. So let's do it. So as you can see, our sorted list now contains this object first, because 19 is the smallest age, and then this and this. Now you might see that there are two 20s. So how do we control which one comes first? Well, by default, it will just give us the result in the way we passed it in the original list. So since Nandini came before Manjeet, in the result also Nandini will come before Manjeet. But what if we wanted to sort it even more? What if we want to sort it in such a way that first we go by age, and the second key will tell us that if there is a clash in ages, we have to go alphabetically by the name. So in this case, we will create a second key. And how we do that? Well, if you go to this step, over here what we're doing is we're doing the same sorted function, but now the lambda We'll again take one parameter, which is I, which is going to be each object in this iterable list, and we're going to take two keys. So the first key will be the age key, and the second key will be the name. So it will first sort on age and then on name. So now if you see, the result should be that Manjeet will come before Nandini, even though the ages are 20, because M comes before N in the alphabet. As you can see, this is the result. Now, if we wanted to do the same thing, but in a descending order, all we have to do is after this key parameter, we have to give another parameter called reverse, and we have to give it true. So if we did this, now you see this, or if we do it on this one, to be more clear. Now, if I execute this, basically this whole whatever result we get will be backwards now. Oh wait, I did not enter it in the sorted function. So this should come within the sorted function over here. So now if we execute this, you will see Nandini comes first, Manjeet comes second, and then Nikhil comes third. Because we've done the reverse, we use the reverse keyword as true, reverse parameter as true. In this video, we will be covering the topics of map, filter, and reduce functions in Python. Now, Python provides several functions that enable functional approach to programming. And since functional programming is all about expressions, some of these expression-oriented functions of Python are lambda functions, list comprehensions, map, filter, and reduce. Now, we've already covered the topic of lambda and list comprehensions. Now, let's cover the topics of map, filter, and reduce. So to start off, let's look at the map function. The map function takes in two attributes, a function and a sequence. A function is basically some user-defined function or any function. A sequence is basically an iterable object like a list or a tuple, for example, or a bunch of lists and tuples as well. So let's look at an example. So one of the most common operations that we do with something like a list is doing an operation on each of the elements in the list and then outputting a new list with the values as whatever we have modified to the original items of the list. So what if we did the square of all of these items in this list, and we want to create a list based on that? So we can basically iterate through it, and we can do a square function and then append those values to a new list called squared. And when we do this, for example, over here, you can see when we print squared, we should get the list of whatever square values we have for the original list. But this is slightly a bit tedious. And what if we had a method that, or what if we had a technique wherein we could basically pass a function that we have that we want to do and a sequence on which we want to apply this, and we pass it to a function, and this function basically takes care of applying whatever operations we want to do on each element of a sequence. So this is where the map function comes in use. So let's look at how we use the map function over here. So if you look at this, I've defined a square function. So the square function basically returns, takes an argument x and returns the square of it. And I have a map function which takes the square function as one of the arguments, and the list or an iterable as the second argument. So this map function creates a map object, if you see here. So let's just do it one by one. So I'm creating my list, and I'm going to create my function called square, and I'm going to send this to the map function. So I'm sending this the first argument as the function that I want to do, and the second argument as the list that I want to apply it on. Now let's list out all the items that are in this map object. So if you see, it creates me a list with basically the squared items, and this is exactly what we needed. And another way of doing the same thing would be just going through a for loop in each of the map objects and printing each, which would give me the same results. So if you see here, I found a very neat way of passing a function and an iterable, and using the map function to apply each operation that is part of the function, or applying the function on each item in the iterable. So as you've seen, we basically passed in a user-defined function, and we applied it to each item in the list. Then the map calls the square function on each list item and collects all the return values into a new list. And because map expects a function to be passed in, it also happens to be one of the places where lambda functions are appearing a lot. So let's look at an example where we do the same operation using a lambda function. So if you see here, I have a lambda function where I'm passing 8 as the function argument, and what this lambda function takes is some variable x or some argument x, it does its square and it returns at x. And this x is basically going to come from each element that is present in this list called items. And when we list down these, you will see it basically does the same thing for us. It creates a list with squared items. Now we can also pass, instead of passing an iterable itself, we can actually pass a sequence of functions and use the lambda function to perform a sequence of functions on particular items. So let's look at a new example, a slightly different one. So we're going to use a numpy module for this. Don't worry, we're just using it to use the square root function that is present in the numpy module. We will be learning about numpy in a later section. So we're going to import this first. And now I'm going to define 3 functions called square, cube, and square root. So once I've defined these, basically they're returning the square, the cube root, the cube, and the square root of some integer x. And now I'm going to create a list of these functions that you've just seen. And we're going to use a for loop, and we're going to iterate through a range from 0 to 4. So, and we're going to pass this, and we're going to say that we want to apply some function. We want to apply some function x, and we want to return that using this lambda function. Now what values this x will take is based on whatever functions we've stored in this variable called funcs or funcs. And in funcs, we have a bunch of functions called square, cube, and square root that we have defined earlier. So what we're going to do is we're going to apply each of these functions to R, and R will take the values 0 to 4. And now let's see when we print this, what values we get. So if you see here, we get a list of squares, cubes, and square roots for integers 0, 1, 2, 3, and 4. So this is another way of using the map function and lambda functions together to apply multiple different operations to a bunch of iterables. Now for our next example, what we're going to do is we're going to create a function that basically what it does is it creates the uppercase of some string that we pass to it, right? So that's what we've done here in this function called toUpperCase. So let's first define this function. Now we have a print function basically which is going to print each object in a particular which is going to print each element of a particular object, and is going to at the end of it, and the end of printing, we're going to give a small space for printing a new line basically. So let's create this also, this print iterator object. Now what we're going to do is we're going to pass a string with the letters A, B, and C to this function, and we're going to we're going to apply the uppercase function to this string. Now if you remember, string is also an iterable where it's a sequence of 1 character strings. So this whole string is basically a sequence of 1 character string A, 1 character string B, and C. So we're going to, we can pass a string as an iterable to the map function because it will apply the operations on each of these characters. So let's see what happens when we do the uppercase function. We apply the uppercase function using the using mapping to this string A, B, and C. So if you see, it's created me a list with capital A, capital B, and capital C as we had expected, because we have applied the list function to the map object. Now, in the next step, what we're going to do is, we're going to do a very similar thing. We're just going to, instead of simply mapping and creating a list out of it, we're going to store the map object in a variable called map iterator. We're going to print what type of object it is, and then we're going to print out each of the elements using the print iterator function that we defined here. So let's do this. Now if you see, the class, the type of object is of class map, and the objects, elements inside the object are A, B, and C. Moving on, let's look at now an example where we're going to pass multiple arguments. So instead of one iterable, we're going to pass multiple iterables now, and we're going to apply some sort of an operation. So if you see here, what we have done is we've created two sequences. One is a list of some numbers, and another is a tuple of some numbers. So just to show you, let me first copy this here. Yeah. So if you see here, I have a list and a tuple, and I'm passing both of these, if you see, to this map function. And before that, I have defined a lambda function as the operation that I'm going to apply. And what this does is it takes 2 arguments, x and y, and it returns the product of both of these. Where does it get x and y from? So the x it gets from this, this sequence, which is a list, and it takes y from this sequence, which is a tuple. So what it's going to do is going to take x as 1 and then y as 5 in the first step, and it's going to return the product as 5. And then the next step is going to take 2 as x and then y as 6, and it's going to return the product of that, and we're going to get 12, and so on. We're going to get 21 and then 32. These values are going to be stored in the map iterator, which is a map type object. And when we use the print iterator function, it's basically going to print out whatever results we got through this mapping. So let's execute this, and as you can see, this is the result we got: 5, 12, 21 and 32, which is what we wanted. So the next part, the next function that we're going to discuss is the filter function now. Now a filter function is basically, again, it takes two arguments, a function and a sequence, and a function basically tests if each element of a sequence is true or not. Now a sequence, so this filter function will basically take two arguments. So one is the function, and this function is basically going to test if each element of a sequence is true or not, and it's going to take another argument called sequence. And this argument sequence is the list or the tuple or basically any sequence or iterable that needs to be filtered. And it can be, as I mentioned, it can be sets, lists, tuples, or containers of more iterators. And what this function will return is an iterator that is already filtered. So let's look at an example now. So we have this list R, which we've generated, which is basically numbers from -5 to 4. So if I create this list here, you can see it will create a list of -5 to 4. Now, if I wanted to extract only the values that are lesser than 0, well, I can use a for loop and use a if condition to check this, right? So if I did this over here, you can see it returns me some list called result, which contains only the values lesser than 0, which is basically checked through this condition. What if there was a neat or a more convenient or a more organized approach to doing the same thing? Instead of creating a loop ourselves, what if we defined a function where we are going to do the test, or we're going to create the condition, and we're going to pass this to a particular function and then apply that particular operation on every object of some sequence? Well, just like mapping, we have a filter function to do this. And in this example, what we're going to use is the lambda function, which takes an argument x, and it checks for some condition x lesser than 0. And where it's going to get the x from is some sequence R, which in our case is the numbers from -5 to 4. And the filter will basically create a filter object type, which contains only the objects from R that meet this condition, that is, x is lesser than 0. And when we use the list operation on top of it, you will see it results in a list with the values that have met my condition. So for a second example, what we're going to do is we're going to create a list which contains a bunch of letters, and we're going to only extract the vowels from these bunch of letters. So let's look at what we have here. We have some letters D, A, T, J, K, O, P, L, and we only want the vowels from this. So we want to filter only the vowels. So we can use that using the filter function by first of all defining a function that returns true if a check is met that one of the letter matches one of these letters in this list called letters. And if it doesn't, it returns false. So this is our condition that we've created. Once we create this condition, this function that checks this, we can pass this function and the sequence into the filter function, and then we can list out whatever we get. So you can see our filtered list contains only A and O, which is basically the only vowels that are present in our original list. Finally, we have the reduce function. This reduce function is basically a functools. It's in the functools module of Python 3.0. And what the reduce function does is it applies a function of two arguments cumulatively to the elements of an iterable, and it starts with an initial argument, and it returns a single result. So let's first import this function. And once we've imported it, let's use it in this example that we have here. So in this example, what we're going to do is we have some list called numbers, right? What if we wanted to get the sum of each element in this list? Well, we can iterate over it and store it in some variable called total in each step, right? This is what we would typically do. And in this step, what you can see is the loop basically iterates over every variable in numbers and accumulates them in total. The final result is the sum of all the values, which is the value of 10 over here. In this example, the variable total is what we call an accumulator, and we can apply the reduce function to do the same task. So how do we do it? Let's first of all create a function called myAdd, where we're going to take two variables, two arguments, and we're going to return the sum of it. Okay, so let's define this function, and now we have our list called numbers, right, which contains 1, 2, 3, and 4. Now let's do reduce myAdd to numbers. Now when I do this, when I use this function, what it will do is, it will apply the function of myAdd. It will take basically each and every element in a sequence. So it will take 1 and 2, then add them together, and then it will create, basically what it will do is, it will take 1 and 2, add them together,